Hi everybody, Patrick here from engineeringshot.com, electroniclessons.com, and paintballprops.com. This is video 2 of 2. It is our first set of tutorial videos for the Arduino Protoboard, currently on Kickstarter. Check it out if you haven't already. In our last video, we talked about how to hook up our LCD, our light-dependent resistor circuit, our voltage divider, and our button. And we've talked about the code. We've got to this point where we've got a light, basically a light meter. It changes the value from the ADC, analog to digital converter, changes depending on how much light is on the light-dependent resistor, buried right behind those wires right there. Now, in this video, what we're going to do is we're going to change it up a little bit. We're going to take the code that we started with in the last video. The last video is linked below, and we're gonna upgrade it. We're gonna make it so when we press a button, it tells us if we have bright light, medium light, or low light and darkness. So just by looking at this, you can use your own LDR. But in the case where I'm in low light right now, the ADC is giving us about 700 in that range. And if I put a bright light on it, we go below 500, down to about 350. And in darkness, we go above 900. So let's talk about the changes we're going to make to the code. We're using the same connections discussed in video 1. One end of our 10K resistor is connected to the 5-volt line. The secondary side of the LDR, the light-dependent resistor, is connected to ground. And the V+ line in the middle, the divider line, is connected to the A0 line, which is fed to our ADC. The LCD connections are as seen in yellow, and our button 1 connection is tied to IO pin 2. Same connections as video 1. If you haven't seen video 1, that one goes into more depth. In any case, let's move on to the code. Most of this code has been discussed in the first video, but I've made some tweaks. This code segment will be broken up into 2 parts. In any case, at the top, we include our liquidcrystal.hr LCD library that'll allow for us to easily use the LCD. We define the LCD pins, and there's a full list of a lot of comments here telling you exactly how to hook up your LCD. And we define our button and allocate it to IO pin 2. Result is just a register. We're going to use it as a register, and we're going to set it off as a value of 0. In our void setup, we set up our LCD to be 16 characters per line and 2 lines. When we clear the LCD, define our button as an input, and wait 250 milliseconds before starting our void loop. Our void loop is very simple. If the button is low, then basically what it does is it takes a reading from the analog 0 line from our voltage divider, places that value into result, and then we call the decode function. We'll get to the decode function in just a second. But the button output is normally high. When you press the button, it sinks that voltage, it bleeds that voltage to 0 volts, which is a low. So if the digital read button is low, then we take a reading off analog read 0, and A0, and then we decode it. Now let's talk about the decode function. The decode function looks a little bit intimidating, but it's actually quite easy. What it does is it takes the value from the ADC stored in result, and it compares it against several different numbers. In the case of result equaling being less than 500, the LCD will be set to the upper left-hand corner, and it will print light level colon. Then it will print to the lower line left-hand corner high bright, so light level high bright. It will wait 3,000 milliseconds, so 3 seconds. It will clear the LCD, and then it will essentially go back to void loop and wait for you to press a button again. If the result is less than 800 but higher than 500, the LCD will print light level colon medium low light. If the light level is higher than 800 but less than 1500, the LCD will print light level low darkness. We'll wait 3,000 milliseconds, 3 seconds, clear the LCD, and delay. So it's taking that analog value and it's comparing it against different numbers. So if it's less than 500, it's high, it's bright. If it's more than 500 but less than 800, it's medium low light. But if it's higher than 800, less than 1500, we get light level, low, darkness. It's just a simple decoding sequence taking the analog to digital reading and comparing it against numbers that we've determined based on our LDR output, our reading on the LCD from video 1 of 2. So let's program this code in and see where it takes us. On top of that, all of these code samples will be provided in the user manual. If you haven't checked out the Kickstarter, it's linked below. Just to give you an idea of where everything is, our LCD is here, our light dependent resistor is right here, right behind this blue wire, and our button 1 is right here. So now let me plug it in. Once I plug it in, the LCD is blank, and I'm in medium light, I'm in room light, low light. Press the button, light level, medium, low light. After 3 seconds, the LCD is cleared. So if I take the flash on my phone, place it on the light dependent resistor and take another sample, light level, high, bright. And then after 3 seconds, it disappears. What if I place my hand over the LDR, casting a shadow, light level, low, darkness. So in these 2 videos we've learned about voltage dividers, how to make a variable voltage divider using a light dependent resistor and a fixed resistor, how our analog to digital converter works, how to decode those values, and how to use if statements using digital reads and a button. So lots of stuff to be learned. If you haven't checked out the first video already, check it out below. Lots more videos like this coming. If you haven't checked out the Kickstarter, I appreciate if you also clicked on the appropriate link below. Thanks for watching. I hope you found this video helpful.